Imagine you are standing at the edge of space. You are about to step into a world unlike any other. This is not a world of solid ground, of mountains and oceans. It is a world made almost entirely of sky, a vast, swirling, endless ocean of gas. You are preparing to descend into the atmosphere of a gas giant. Below you, clouds stretch out to the horizon in bands of orange, white, and brown. They move in great rivers of wind, some wider than our entire planet. What secrets are hidden beneath those beautiful churning layers? What wonders and mysteries lie deep within that colossal abyss? Your journey downwards begins. The first layers of cloud are thin and wispy, made of frozen ammonia crystals. They glitter like diamond dust in the faint sunlight. The pressure is still low here, but it is building with every meter you descend. You sink deeper through different layers of cloud, each with its own color and texture. The air, if you could call it that, grows thicker and warmer. You are now inside the planet itself, floating in its very substance. This is a place where there is no surface to land on, no solid ground to ever touch, just an ever-deepening, ever-denser atmosphere that goes on for thousands of kilometers. Down and down you go, into the heart of the storm. The winds howl around you, faster than any hurricane on Earth. Lightning flashes, not just in small bursts, but in enormous sheets that illuminate the clouds from within. These superbolts are hundreds of times more powerful than anything we experience. The pressure becomes immense, like being at the bottom of the deepest ocean on Earth, and then far, far greater. The temperature also rises dramatically, from freezing cold in the upper clouds to scorching hot in the depths below. It is a truly extreme environment, a place of immense power and cosmic violence. Yet even in this seemingly hostile place, a question begins to form in your mind. It is a question that has fascinated scientists and dreamers for decades. Could something live here? Is it possible that in this endless sky, amidst the storms and the pressure, life has found a way to exist? When we look up at the night sky, we see tiny points of light. Some of those points are stars, but others are planets right here in our own solar system. Among them are the gas giants, Jupiter, Saturn, Uranus, and Neptune. They are completely different from our own world. Earth is a small, rocky planet with a thin blanket of air. These giants are enormous spheres of gas and liquid, with no solid surface to speak of. Jupiter is the king of them all. It is so big that all the other planets in our solar system could fit inside it. Its size is almost difficult to comprehend. These worlds are mostly made of the lightest elements in the universe, hydrogen and helium. These were the raw materials from which the Sun and all the planets were born. On Earth, hydrogen and helium are light gases that quickly escape into space. But the gas giants are so massive that their gravity is incredibly strong. Their powerful gravity holds onto these light gases, building up colossal atmospheres that are thousands of kilometers deep. They are like small, failed stars, full of the same ingredients but without the immense mass needed to ignite nuclear fusion in their cores. They are the titans of our solar system. The atmospheres of these giants are not calm or peaceful. They are dynamic, chaotic places. Jupiter has its great red spot, a storm that has been raging for centuries and is larger than our entire planet. Saturn has winds that scream around its equator at over 1,800 kilometers per hour. Neptune has the fastest winds in the solar system, creating violent, dark storms that appear and disappear. The idea of life existing in the clouds of a gas giant is not just science fiction. It is a concept that serious scientists have considered. The famous astronomer and science communicator Carl Sagan, along with his colleague Edwin Salpeter, explored this very idea in the 1970s. They imagined a whole ecosystem of creatures floating in the vast atmosphere of a Jupiter-like planet. This wasn't just a wild guess. It was based on what we know about the chemistry and conditions that might exist there. They gave these hypothetical creatures names, sparking the imagination of a generation. Sagan and Salpeter proposed three main types of creatures. There would be tiny sinkers like microscopic plankton on Earth, using sunlight in the upper atmosphere to create food. Then there would be floaters, enormous balloon-like beings like living airships kilometers across. These gentle giants would float through the clouds, perhaps feeding on the sinkers or producing their own energy. And preying on the floaters would be sleek, jet-propelled hunters, the predators of this aerial ecosystem. This vision painted a picture of a complex three-dimensional world teeming with life. For this kind of life to be possible, certain conditions would need to be met. There must be a region in the atmosphere where the temperature is just right. Not too hot, not too cold. On Jupiter, there is a layer where the temperatures are similar to those on Earth. There would also need to be a source of energy, like sunlight from above, or the planet's own internal heat from below. And most importantly, there must be the right chemical ingredients. Gas giants have an abundance of carbon, hydrogen, nitrogen, and even water, the basic building blocks of life as we know it. So, the fundamental ingredients seem to be there. The chemistry is right, the energy is there, and there are stable zones where temperatures could support complex molecules. The biggest challenge is the environment itself. The constant, powerful winds and the crushing gravity would pose immense problems for any organism. Any life form would have to find a way to stay afloat, to avoid being dragged down into the scorching depths where it would be destroyed. The question is not whether the ingredients for life exist, but whether life could overcome these incredible physical challenges to get started and evolve. Life, as we know it, is a delicate thing. It thrives within a narrow range of conditions. On a gas giant, the most fundamental force of nature, gravity, becomes one of the greatest obstacles. High up in the wispy ammonia clouds, the temperature plummets to a bone-chilling -150 degrees Celsius. Conversely, if an organism were to fall into the depths, it would face the opposite problem. This creates what scientists call a habitable sandwich. There is a layer that is too cold on top and a layer that is too hot on the bottom. In between, there might be a narrow zone where the temperature is just right. There is another danger in the skies of a gas giant, one that is completely invisible. This is the threat of intense radiation. Jupiter, in particular, is surrounded by a powerful magnetic field far stronger than Earth's. This magnetic field traps a donut-shaped belt of high-energy particles, electrons and ions, that zip around the planet at nearly the speed of light. This radiation poses a severe threat to the upper atmosphere. Any life form floating too high would be bombarded by these energetic particles. This radiation can tear molecules apart, scramble DNA, and destroy living cells. So how could life possibly conquer the endless fall? One of the most captivating ideas, first proposed by Carl Sagan, is the concept of a floater. Imagine a creature of immense size, a living balloon drifting serenely through the clouds of Jupiter. These would not be small organisms. They would need to be enormous, perhaps kilometers across, to achieve the buoyancy needed to stay aloft in the dense atmosphere. Their sheer size would be their survival mechanism. Like a hot air balloon on Earth, they would be little more than a vast, thin membrane enclosing a gas that is lighter than the air around them. This is actually a beautiful and elegant solution to the problem of gravity. Where there are grazers, there are often predators. In a sky filled with giant, slow-moving floaters, it is natural to imagine that another form of life would evolve to hunt them. These would be the hunters, the sharks and lions of the Jovian atmosphere. But they would look nothing like their earthly counterparts. A hunter on a gas giant would face the same buoyancy problem as its prey. It could not afford to be a heavy, muscular creature. It would need to be a masterpiece of lightweight design, a creature built for speed and agility in a three-dimensional world, while remaining light enough to stay afloat. Every complex ecosystem needs a foundation. On Earth, that foundation is provided by plants and algae, which capture energy from the sun. In the skies of a gas giant, this role could be filled by vast clouds of tiny organisms known as sinkers. As their name suggests, these would be microscopic life forms, slightly denser than the surrounding atmosphere, that are constantly, slowly sinking. They would be the plankton of this alien ocean of air. Their life would be a one-way journey downwards, from the upper atmosphere towards the warmer depths below. Their sheer numbers would form the base of the entire food chain. Our most intimate look inside a gas giant's atmosphere came in 1995. NASA's Galileo spacecraft, after years of orbiting Jupiter, released a small probe that plunged directly into the planet's sky. For 58 minutes, as it descended on its parachute, the Galileo probe sent back a stream of data before it was finally silenced by the immense heat and pressure. It was a one-way trip into the heart of the beast, and it taught us more about Jupiter's atmosphere than we had ever known. It was our first and only direct taste of what it is like inside those churning clouds. The question of whether life exists on a gas giant remains one of the most tantalizing mysteries in science. We have speculated about floaters, hunters, and sinkers, but for now, they remain beautiful and compelling ideas. The search for real answers continues, driven by our insatiable curiosity. Future missions to the outer solar system will be key. We have only sent one probe, Galileo, into Jupiter's atmosphere. This search also extends beyond our own solar system. With powerful new telescopes like the James Webb Space Telescope, we are now able to study the atmospheres of gas giants orbiting other stars, the so-called hot Jupiters. Our exploration of gas giant atmospheres, both real and imagined, leaves us with a profound sense of wonder. It pushes the boundaries of our imagination and forces us to think bigger. We started with a simple question. Could life exist in such a place? We may not have a definitive answer yet, but the journey to find one has revealed a universe far richer and more varied than we might have thought. The great swirling clouds of Jupiter and Saturn will continue to beckon, holding their secrets close. They challenge us to keep looking, to keep questioning, and to never stop imagining what might be possible in a universe filled with endless skies.